This is a simple project that uses one sensor, one LED, and 13 lines of code. In my previous video, I introduced the idea of using two simple Arduino projects to show how instructors might incorporate health and wellness principles into intro-level computer science classes. In this video, I'll explain how to assemble the first of these projects. By the end of this video, you will understand the different components used, how they work, how they are connected to each other, and why. In the following video, I will show you how the code works and demonstrate the finished project. I call this a reverse candle because it is basically a light that you turn on by blowing on it. For this project, I'll be using an Arduino Uno, a single LED, a resistor, and a hot wire anemometer. I suggest using a breadboard with wires to connect them, although for demonstration purposes I'll be using my own system with alligator clips. Here is a little explanation of each of the three parts. An Arduino is an open-source microcontroller that was first developed by the Interaction Design Institute Ivrea about 15 years ago. They're now made by a whole bunch of different companies, and they come in a whole lot of different shapes and sizes. I've seen them sold for as little as $5 at a local surplus store. Basically, they're a cheap and easy way to prototype interactive electronic devices. There are a lot of different sensors and outputs that you can get that interface really seamlessly with Arduino, and I'll be using a few health and wellness related sensors for these projects. Arduino has its own integrated development environment that you can download for free. It uses a version of either C or C++. I will be using the C++ variant, which you'll see in the next video. Now for our purposes, an LED is basically a light bulb that can be turned on and turned off by running a current through it. We also need a resistor because the Arduino provides more voltage than the LED can absorb. Now the anemometer is an interesting little thing. An anemometer is a device that measures wind speed, or in our case, breath speed. The most common type that you might see is on a weather station, and that's called a spinning cup anemometer. Those use cups at the end of arms that catch the wind and spin around kind of like a pinwheel. This version is called a hot wire anemometer, and it is a lot more compact. Basically how it works is that there's a little wire in there that gets heated up, and then the sensor measures how much electrical power is needed to maintain that temperature. That means that it can detect tiny fluctuations in airspeed a lot more accurately than a pinwheel or spinning cups could do. So it'll work really well for detecting breath, which is our goal here. Arduinos are small, and all of their inputs and outputs and flashing lights can be a little intimidating at first. So what I've done here is made a board that shows just the parts we're going to be using. Each one has a wire that is connected to the Arduino. There are only 5 things that you need here. The anemometer needs to be connected to power, in this case 5 volts, and a ground. That'll heat up the wire and make the sensor inside work. It also needs to be connected to an analog input, which happens to be called A0 in my case. That is where the anemometer will send data to the Arduino. The other bit is for the LED. An LED usually has 2 leads of different lengths. The shorter one gets connected to the ground, and the other gets connected to a digital output. In this case, it's pin number 13. So when the anemometer detects breath, it sends a signal to the Arduino. The Arduino then sends a signal to the LED to make it turn on or off depending on the speed of the breath. So that is all you need to put this together. In the next video, I will demonstrate the code that makes it all work. Again, I'm Michael Chergosky, and thank you so much.